And we're doing them out of order. We're doing section 1.5 today. We're actually going to be doing notes. Did I put 1.5. We're actually going to do chapter 1 out of order. So 1.5, absolute value. Math magic. Okay. So absolute value is distance from a number and 0 on the number line. How far away it is from 0 is its absolute value. That's how it's measured. I actually like to think of that absolute value as the size of a number. How big is that number? Okay. Absolute value of 2 is 2. It's 2 units big. Absolute value of -3 is 3. It's 3 units big. Okay. We don't measure length negatively. We don't measure size in negative sizes. Size is always measured positive. That's why I like to think about absolute value as being size. And absolute value is always positive. It's how big it is. It's its size. It's always a positive number. Okay. Opposites. Two numbers that are the same distance from 0. Okay. Opposites are two numbers that are the same distance from 0. 2. What's the opposite of 2? -2. What's the opposite of -5? 5. Those are opposites. Good. Nice, easy. I like starting out with things that aren't too hard at the beginning of the year. Okay? As it should be. Kind of get your feet wet before things get difficult. Every class is like that. Some get harder faster. Okay. Questions? Okay. Using number lines to model addition and subtraction. Now, I don't expect you to use this for your addition and subtraction every time. Okay. However, it's a good idea to be able to visualize adding and subtracting using a number line. It's a good visualization. So when you do this, first thing you do is plot the first number. Make a dot on 3. That's why I start. First number, I start at 3. What am I doing to 3 in that first one? Adding 5. Is it positive or negative? Positive. Positive. Which direction do I go for positive? I go to the right. You know, that's why teachers never know the right and left, math teachers. Because these are left hand to point to the right and the right hand to point to the left. You notice that? Okay. So I move to the right. How many units? 5. 1, 2, 3, 4, 5. There we go. Piece of cake. Now, do you need to do this to add 3 plus 5? I certainly hope not. I certainly hope that you can add 3 and 5 and get 8 without having to bust out a number line every time. Okay? Now, but there are times that we will do stuff to help you visualize, to help you see it in a different way. Okay? So let's do the same thing on the next one. Plot the first number. So I put a dot at 3. And this one I'm adding -5, so I would want to move to the left 5 places. 1, 2, 3, 4, 5. So my answer is -2. Does it make sense? Do those two. Okay. So next one, we start at -3. And we add 5. 1, 2, 3, 4, 5. And we get 2. Last one we start at -3, and we do 5 in the negative direction. 1, 2, 3, 4, 5. Get -8. Easy peasy, right? Good. Okay. Once again, do I expect you to bust out a number line every time you're adding numbers? No. But if you want to, if you really want to, I can provide you with a number line to do it. Okay. It does, and it helps you see it. Okay, it really does. So here we go. Next page. Okay. Adding real numbers. Okay. So first one, -12 plus 7. Are they the same sign? That's the first thing you want to ask yourself. If you have negatives and positives that they're adding together, are they the same sign? -12, 7, they're opposites, right? One's positive, one's negative. If you have a positive and a negative, this is what you do. You take the larger one, subtract the smaller one. Ignoring the signs. What's 12 minus 7? 5. So this is 5, either positive or negative. It's negative because the larger number was negative. We've got -12, positive 7, so my answer is going to be negative. Does that make sense? Okay, so my answer is -5. Piece of cake, right? Okay. Next one, -18 plus -2. They are the same sign. They're both negative, so my answer is negative. And I do 18 plus 2. What's 18 plus 2? 20. So my answer is -20. That's a big O -20. Okay. Next one. -4.8 plus positive 9.5. Same sign or different signs? Different signs. Is my answer going to be positive or negative? Positive, because I've got 9.5 and 4.8, so it's going to be positive. And what do? I subtract the larger from the smaller. Now I'm going to do this over here. Bust out my mad subtraction skills. Can I take 8 from 5? No, 5 is smaller than 8. So what do? I have to borrow. Take 1 from 9, make that 8. Make that 10. 15 minus 8. Don't worry, you won't have to do this all the time. 15 minus 8 is 7. Bring down the decimal point. 8 minus 4 is 4. 4.7. Because my answer is positive, and I determined my answer was positive before I did the work. Does that make sense? Okay, last one to do here. Thanks. Fractions. What do I have to do with fractions? Before I can add or subtract, what do I have to add? Add or subtract fractions?
Oh, same denominator.
Common denominator. Okay. You will not be doing a lot of this all by hand, but I do want to do this first day by hand. Okay? So, fractions, common denominator. Does anybody know my common denominator between 4 and 6? Yes. It's 12. 12 is the smallest number 4 and 6 go into. So I want to do this as something over 12 plus negative something over 12. That's my common denominator. 4 times what? What times 4 gives me 12? 3. So I have to do the numerator and the denominator both times 3. 3 times 3 gives me 9 twelfths. What times 6 gives me 12? 2, right? 2 times 6 is 12. 2 times 5 is 10. Now, the nice thing, once you get a common denominator, my answer is going to have that denominator. And I just add or subtract the numerators. What's 9 minus 1?
8.
Yeah, 9. No, sorry, I meant 9 minus 1. I did 9 minus 1. What's 9 minus 10? Negative 1. Negative 1. Okay. Piece of cake. Right? Yeah. How many of you were not happy about having to do that on my end? Be honest now. You will have use of calculators for most of the stuff that we do here. What time? Thanks for sharing. Before you go, let me stamp your stuff wherever you're at. I will stamp it before you leave, okay? So when it's 2:30, it's time to go. I'll do the stamps. Good. We'll do it. Okay. Subtraction. Subtraction's not I don't like to do subtraction. I'd rather do addition. Change your subtraction to addition. Change your subtraction to addition, and what do? You change the sign of the number following. You always change two things when you change your subtraction to addition. Okay, so instead of negative 8 minus negative 13, I have negative 8 plus 13. Okay, so negative 8 plus 13, what do I get? I get 5. Same thing on this one. Instead of 3.5 minus 12.5, I make it plus negative 12.5. This is a little harder, but it's not that bad. 12.5 minus 3.5, right? Because if they're different signs, you subtract, give your answer the sign of the larger one. 5 minus 5 is 0. 12 minus 3, just what's 12 minus 3? 9. So I get 9, and my answer is negative. How are we doing so far? So far, so good? It's easy. It's early in the class. It shouldn't be too hard. Okay. Now, the next part's kind of important. It's always true that A plus B equals B plus A. If I am adding two numbers, it does not matter which one's in front. If I'm adding a bunch of numbers, it doesn't matter the order that I'm adding them together. How many of you, when you've had to add a bunch of numbers together, you group them in your head? It's like, ooh, these two make 10, these two make 10, these two make 10, that gives me 30, then I add this one to it, and I add that one to it, and I add that one to it. You can do that because when you're adding numbers, it doesn't matter which order they're in, if it's addition. Okay, 2 plus 3, 3 plus 2 equal the same thing. Doesn't matter the order. Doesn't matter for subtraction. Does order matter? Is B minus A the same thing as A minus B? Can somebody give me an example of where that would not be true? If I take two numbers and swap them for subtraction. 9 minus 2 and 2 minus 9. Those are not equal. 9 minus 2 is 7. 2 minus 9 is negative 7. They're not the same. Can you think of any time where one number minus another number is the same if you swap them. 1 minus 1, 2 minus 2, 3 minus 3, -5 minus -5. The only time this works is when A and B are the same thing. So generally speaking, it doesn't work. So generally speaking, we do not say subtraction. We can do that. By the way, this is the commutative rule because we're moving numbers. When you commute, you move. I can commute for addition. I can commute for multiplication, but not for subtraction or division. Okay, so let's read this one together. Then I want you guys to work on it. Give it a shot by yourself before we do it. Problem number 4. A reef explorer dives 25 feet to photograph a coral, then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. Then the diver rises 29 feet to see an underwater cave. Write an expression to represent this dive. I don't want to know where they are. I want an expression that represents they went down, they went up, they went down, they went up. In other words, this number plus this number plus this number plus this number, or this number minus that number, or something like that. A numerical expression is where you have numbers added or subtracted together, but there's no equal sign. Okay, does that make sense? I want you to come up with one. Take a minute. Okay, so there are a couple of expressions you could do. A couple of different ways you could write this. We could probably come up with a lot of them if we really, really wanted to take the time. But the easiest way to do is think about it. And if you look at it and read the problem carefully on here, it's actually color-coded to help you out. When they're going down, what color is the number? Right. When he's going up, what is it? Blue. So all the red ones would be positive, all the blue ones would be, all the red ones would be negative, all the blue ones would be positive. My bad. Switch that, reverse that. So if I said, okay, I've got -25, 5, plus, and then he goes up 16, plus, -47, plus, and then positive 29. This is one possibility. Now, another possibility, most likely the other one done. -25 plus 16 minus 47 plus 29. The most likely other expression. Is it possible that there are other expressions to show what's going on? Yes. Okay? Yes, it is possible that there are other ones other than these two. These are the two most likely candidates. If this was a test question, I'd figure 90% of you would have one of these two. The other 10%, I would, if it wasn't one of those, I'd look really close to see what you have. Possible to have a correct answer and have it not match here. Not likely that it's going to be because there's probably something wrong, but because these are most likely, but it is possible, and I would look. Okay? Questions about that? Okay, what's the answer? What's his location in the cave relative to sea level? In other words, what do those add up to? -32. Is that right? -32. I got -32. Well, I had that for more than one person. Okay. Good. Questions? Okay, and that's it, right? There's nothing else on the paper? Awesome.